Hello there. Today we are going to be modeling a parking garage by the architect Touzet Studios. It is basically a parking garage in Miami, Florida. It is located in the neighborhood of Coconut Grove. Uh, what it does have is it has these metal components that serve as a screen, and they sort of hide the cars. Uh, Let me open up some pictures of how it looks. So, as you can see, this is an image of a rendering. It's actually been completed, but here's an image of what it looks like. And the architect, they had a vision that this sort of surface would mimic a seashell, and that this is very synonymous with what you would expect in Miami in terms of design. So we're going to model sort of an interpretation of this, and we're going to show what would be a good strategy to get this effect, and what would be less a worse strategy as well. So we'll sort of go over these two things to better understand this. Okay, so this is just sort of our final result. Let's start from the beginning. So I'm gonna open a new file. I'm gonna put my units in millimeters. I am okay. So I am going to first of all draw the perimeter of this parking structure. So I am going to make it 13,000 millimeters, which is 13 meters, and I'm going to make it 60,000 millimeters, which is 60 meters. So let me just double check. And then I want to make it 16,970, so almost 17 meters. So I will first put in my bifocals. I will get a curve. I'll get another curve. So I'm going to select this curve right here. I'm going to set this curve right here. I want to join the curve right here. Oops. So now this becomes one polyline. I will select this curve right here. The length. So the length is 16,979. I want to extrude this polyline. Okay, so this is being represented as one B-rep, which is perfect because the next step is I want to create these ribs, so I want to start cutting these intersections here. So I want to deconstruct the B-rep because I want to get these two edges and draw some intersections. So there's 7 edges, so this item, oops. So there's 7 items, so I'm going to put 6 because 0 is the first number. Okay, 3. Okay, so this I'm going to join these curves. Okay, so I want to divide these segments by 450, which is around 18 inches. So I want to use a divide distance command. I'm going to just take my panel, write 450, you can see, and then now I'm going to go to the vector component and do the plane normals because I want to get vertical intersections. So I'm going to go to my brep plane, and then I want to take this extrusion, and voila, you see we have these intersections everywhere. So the next thing that I want to do is that I want to divide these points because I want to create these metal structures that they'll be either 5 or 6 columns high. But the first thing I need to do is I need to partition this list so I can analyze it, because I want to use the evaluate surface command to manipulate my line work that's based on this plane. So I go to split list. So we have, what do we have as simplify? I want to split it, and right now they're represented as branches. I want to flatten it because it's just going to be easier to manipulate. So there's 162 items. I'm going to make the upper limit 161 because 0 is the first number. Let me see the curve. Oops. Okay, so now I have it separated. So now I want to divide these curves because this is the next step, is building those structures. I'll do the same thing here. I want to get my slider. I want both those sides divided by the same number. I'm going to put an upper limit of 6. Okay. Okay, so I want to build this metal structure. So like I said originally, I'm going to use the curve surface to closest point and evaluate surface so it can recognize the direction it's going. So I will, let's see, I'll make it 5. So I'll do the surface closest point. I'm gonna deconstruct this brep because I want to get just that one side. Deconstruct. List item. Okay, so it's this is the side that I am interested in. The points are from these divided points. Then I go to evaluate surface. I connect it to the UV point, and then I connect it to the surface. Now I want to draw a line, so I'm gonna do the line SDL. So the start is going to be at the point, and the direction is going to be at the frame. And I want to do a slider. I want this to go, let's say, I'm going to put an upper limit of 600. I want to put it N. Okay, so it's pointing the other direction. So I'm going to go to my expression editor. Oops. Expression editor and go -x. Okay, so now I have this line that's moving this direction. Now with the evaluate surface, if I wanted to go this or that direction, I can always click it on here. You can see it's going that direction, or you can click in it to go down there. This is a really helpful component because it'll be a lifesaver when you're dealing with curved surfaces and you want to have the lines projecting off the plane. Okay, so we have this element, so I'm going to go and create a rectangle. Now, the first thing I need to also recognize is that I'm going to be creating a rectangle that goes down here, down here, down here, down here, down here. So I need to cull this item. So what I need to do is, when I'm dividing this, I need to do a cull index. And I'm going to put 0. And depending if it's the first or last, I can just reverse the list. I'm going to go reverse. So I've just culled this item because I don't want to include that. So I have this. Now I will create my rectangle. Now I want to make the rectangle 450 by 450, so I'm going to just use my construct domain. And I'm going to set it up so that it is negative x divided by 2, x divided by 2, $450, or maybe it's 400. We'll just see what it is. Oops. This will go to the x. Oh, whoops, made a mistake. That's not what I want to do. What I want to do is I want to draw the x, the square off this point. So I need to go to my endpoint command. The end is here. Now it's going this way. Now I want to extrude it in the Z direction. Let me get a slider with an upper limit. I'll just make a slider like this. I'll make the upper limit 7,000 millimeters, which is 7 meters. And I will put this in negative x. Okay, obviously 4 meters is a little too much. Okay, I wanna keep a little bit of a gap. Okay, so we have the metal structures here. We need to do the same thing here. Now we can just simply copy this, but the thing that we do need to edit is that we need to just get a different side from the brep, decomposed brep. So we have this. We can, why don't we just copy this? Actually, let me put a slider into this component. You can I want to just copy this. And then I'm just going to go to a point here. And voila. So you can see, oh, oops, you know what? I have to also cull the item. So let me go to cull index. Zero. Okay, reverse. Okay. So basically, these are basically the same sizes as that. Now, we want to get this color scheme. So the best way to do is we want to merge these two datas. And the best thing to use is the entwine command, because it is very helpful to use this command because it flattens the geometries, which allows for greater controllability. Now, we can think of some pretty simple ways of getting a color scheme. For example, we can go to random reduce. We have, and then let's flatten this, 810. So we could slider, I'm going to make it 809, color preview, custom preview, seed. So you can see I can reduce the amount of items within the list, and then I can obviously put the seed, but this method isn't very helpful because I don't have controllability of the non-reduced items, which would be the red items. So while this may look cool, it's not really the best method. You could also use the cull pattern method and stick in a bunch of booleans. Let me just make a whole series of booleans. I'll just make the pattern this. Custom and while I can generate a pattern and maybe I can do some interesting things, this is, again, it's not very helpful because I have no way of accessing the red elements. It's just giving me the remainder of the split elements. So if I really want to make this have some greater controllability, the best method to do is to create a dispatch system. So first of all, I'm not going to flatten this. I'm going to keep it as a branched item. I'm going to create a random component. I'm going to set it as integer numbers. I am going to run the list of numbers, which are basic, since it's entwined, they're basically flattened. I'm going to provide a slider for my seed. I'll put a high number. I'm going to create a dispatch condition. I'm going to create two custom preview colors. So you can see how this method allows you to control both split items. I'm going to put it in list A, list B. This is going to be the dispatch pattern. And as you can see, I now have controllability of both items and not just the split item. And obviously, I'm able to run different seed. But also, in addition to this, I can even build off of that and add even more items by increasing the amount of dispatched items. So I can copy this item, feed it into this one dispatch item, dispatch condition, custom preview. Oops. Okay, and I'm going to do the same thing on this second dispatch. So as you can see, I'm splitting the elements into 4 parts. And I can do this continuously. So you can see I can add even more colors to make it even more interesting. So essentially, with this method, I'm taking these entwined elements, and by entwining it, it basically flattens the elements, and I'm feeding the numbers, and I'm able to create a dispatch condition with this method. And I can continuously produce more dispatch conditions, which allows me to control each of these colors and have greater controllability. And the greater controllability is absolutely critical, because when you get into the phase of fabrication and producing a working drawing set, it really comes in handy. Okay, thank you.